So before I answer choice 1, choice 2, choice 3, choice 4, how do I know by looking at an equation whether or not it is linear? Needs to have a y or function notation. Needs to have an x unless it is a constant function. Talk to me about exponents. Yeah. If it shows an exponent, it can only show a 1 as an exponent. Otherwise, it's not linear. So the first thing I'm doing as I'm trying to figure out which ones are linear is I'm scanning through looking for powers. Does A have a power on it? Yep. That means it is not linear. Power, exponent. Powers are exponents. Those two words tend to get used interchangeably. What'd you say, Chase? Square root. That's another one that breaks it. Square root is technically the same thing as a 1/2 power. So even though I don't see an exponent, it's got a square root around it. That is an exponent. It means that it is also not linear.
What about D?
What about E? Good.
D.
Oh, sorry, D. My apologies. What do you notice in D? X has an exponent of 2. Not allowed. Not linear.
And the fraction?
Good question. The fraction. Is there a variable on the bottom of the fraction? No. What does a fraction bar mean? What operation? Yep, that means division. And even though they're not showing it right here, we distribute our division the same way we distribute our multiplication. So if I were to write down an equivalent idea of what they're showing for me here, they basically have something like this where they just didn't distribute it yet. So I can distribute with my division the same way I would distribute with multiplication. With multiplication, each piece gets distributed to, right? Division, it's the same thing. So with this one, I'm going to take the 2 and divide it by the 3. So that would be 2/3 and then x. And then I take the 5 and I divide it by the 3. So plus 5/3. If I wanted to write it so that it looked like slope-intercept form, this is how I would do it from that fraction. There cannot be any variables on the bottom of the fraction. If there are variables there, it is not linear. If it is just numbers, we're good and we distribute that. This one is linear because when I look at this, I have the x there. It does not have any power with it, any exponent, so it's just a 1. It starts with function notation. That's exactly the same thing as y. Whenever you see things like f of x or k of x or h of x or g of x or anything of x, this is all just function notation. And it means the same as y equals. So whenever I see that kind of function notation, I usually don't even read it in my head that way. I see it and I just go, y equals, and then I move on to the rest of it. All right? Which ones of these are linear then? C and E are linear. So what is my correct choice? Choice 1 is my correct choice. I picked this one out because I was getting a lot of questions about this yesterday, and there's a similar one to this on your review. Yes, sir.
So you said it needs a x and y.
So I'd be looking for let me show you 2 more examples of things that are linear. X equals, and then a number. So like x equals -2. That would be a line, but since there is no y in the equation, it's going to be a vertical line that goes just through -2 on the x-axis. But it's straight up and down. It does not have a y in the equation, which means it does not ever touch the y-axis. If it doesn't have a y, it doesn't touch y. Does that make sense? Another thing that would be an example of a linear function that we don't have a good example of right here would be if I just had y equals or function notation equals and then some number like, I don't know, 1/5. That's the same as y equals 1/5. Does that have an x in my equation? So that means it never touches the x-axis, which means it is a back and forth, a horizontal line. So those would be linear also. But notice on neither one of those do I have exponents on any of my variables. Does that make sense? Okay. Rest of class time today is open for questions, whether you still have questions about this or questions from the review. I am happy to look at any of the problems on the review for you. While you guys are pulling out your review and thinking about maybe which ones you want me to work through, I want to show you very quickly on Canvas So I went to modules and I clicked on today for modules. And this is the picture that should pop up down at the very, 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 very bottom. So scroll down until you can't scroll down anymore. Here's a digital copy of the test review. Here's my solutions. All the answers, all my work. If you click on it, it's going to open up for us. Because I saved it as a PDF, it'll open up on your phones just fine. There's all my answers, every single question. All right? Do you guys know how to find it now? Okay. Which problems would you guys like to look at from the review? Number 2, absolutely. Number 2, it says identify the features. So we're going to start off with, is this a line? No, then I would go with non-linear. Next one down wants to know, is it a function, is it one-to-one, or is it neither? We had quite a few conversations yesterday around this, so I want to talk about how you determine these things. First thing we're going to check for is it a function? If it's not a function, we jump immediately to neither. It cannot be one-to-one if it's not a function. Checking for a function is where I used my straight up and down line, my vertical line. Remember, I'm imagining that this vertical line is very, very, very thin. So if I'm using a pencil, it's super thin. I'm going to take it vertically back and forth in front of my graph. And sometimes on graphs like this, it might be a little bit hard to see as far as how many places is it crossing in. Do you guys see how this is tipped ever so slightly to the left? Like if I follow it down, my finger is heading more to the left. If they drew a super precise graph, I would be able to see that even better. So as I'm holding my vertical line here, it's only crossing in one spot at a time. So remember, I have to imagine my vertical line is really, really thin as I'm passing it back and forth across this. The only time I would look at something like this and say, no, it breaks it, is if it is perfectly up and down. If there's a tilt to it at all, it's only going to cross my really thin vertical line in one spot at a time. If I take my vertical line back and forth across this, is there ever anywhere that I could stop this vertical line that this blue M-shaped graph is going to cross my vertical line in more than one spot at the same time? No. Then it is a function. Function, it passed the vertical line test. I don't want to circle function yet though, because if it is one-to-one, that means that it's also a function. So I'm going to go and check that piece next. To check to see if it's one-to-one, again, it has to pass vertically first, or else it's just neither. To check one-to-one after it's passed this way, I turn my line the other way. And I'm checking for the same thing. Is it ever crossing this line in more than one spot at a time? Yes. Then it fails. That means it is a function, but it is not one-to-one. This fails my horizontal line test, yes. So I would say that this one is a function, but I would not circle that 1 to 1. How many x-intercepts do we have? How many places does it cross? Yeah. So here's my x-axis, and as I move across that, every single time the graph crosses the x-axis, that's an x-intercept. And we have to write down the ordered pairs for all of those. So -2, 0. -1, 0. +2, 0. And +3, 0. So far, so good? All right. What about y-intercepts? -4, yes. And when we go to write an ordered pair, I always put the x part first and then the y. What is the x part of this ordered pair? 0. So 0, -4. Extrema. Does anybody remember what extrema means? Yeah. Highs and lows. Highs and lows. I'm looking for any highs and lows to start with. Do you guys notice anything that looks like a hilltop? How many? 2. One right here and one right here. Is one of them taller than the other? They look tied to me. It's kind of hard to see, but if I grab a ruler and I draw like a horizontal line, they look about the same height to me there. If one was like, let's pretend this guy over here was up like this, then one is clearly taller than the other. These, since they are tied for the highest, would both be maximums. This is tied for highest. So these are maxima. Remember, maxima is just the plural form of maximum. So I'm going to say extrema, it has maxima at, and then I need to give the ordered pairs for those. My extrema are locations. I should be able to tell somebody, here's where the high point is, and they should be able to go to the graph, and even like blindfolded, they should be able to point to it. If they can't see the graph, but I give them the coordinates, they should be able to go and find it. I'm going to have to ballpark these, though, because they're not on nice, pretty numbers, right?
Do they have to be whole numbers?
They do not have to be whole numbers, no. So this one over here, like -1.5? So -1.5 for my x. And it goes up to 1.5, 1.2, 1.3, somewhere in there. Just make sure that it's somewhere between 1 and 1.5, because it's not bigger than that. It's not closer to the 2. I'm going to call it 1.3 just so I can really distinguish that from the x part. Where's the other maxima at? Yeah, +2.5 and 1.3. All right, so those are maxima. Are there any minima, low points? Yes. Right down here, I notice a low point. Is it the lowest the graph ever goes, though? No. Since it's not the lowest the graph ever goes, this right here tells me it goes lower, we call it a relative minima. It is a low point. It is a key point of interest. It's not the lowest, so we call it a relative minimum. So I'm going to add that under here. We have a relative minimum at, and now I have to name that ordered pair. 0, -4 is my y-intercept. Is my minimum, is my low point the same place as my y-intercept?
Okay. 0.5 -4.6.
Yep. 4.5, negative 4.5, negative 4.6. Yes. We are going to have to estimate here a little bit. If your estimate shows me, like if I go to the graph and I was like, yeah, I can see how you came up with that number, you're fine. I'm not interested, like, if, oh, I said it was negative 4.4 and you said negative 4.6. I'm not taking off points for something like that. If you tell me that the relative minimum is at 0.5, negative 6, that's different enough that I would take off. End behavior. 2 lines here because we always write 2 math sentences, and they always start the same way. It starts with as, x, and then an arrow. My other sentence, same thing, as, x, and then an arrow. Because one sentence is going to tell me about the left side, and one sentence is going to tell me about the right side. Which one do you guys want to talk about first, left or right? Left. What kind of numbers live on the left side of the x-axis? Negative. So if I want to tell somebody, look as far to the left as you can, I'm going to say as x approaches, x arrow, how do I say left? Negative infinity. That's how I say left side. So as I look to the left on the x-axis, I notice the y values, the f of x's, are going which way? Which way is the graph headed? Down. How do I say down mathematically? What kind of numbers? Negative infinity. It goes down forever. All right. That's my left-hand side. How do I talk about the right-hand side then? As x approaches positive infinity, my graph, f of x, approaches, what's the right side doing? Also going down, so I'm going to have another negative infinity here. So this right here means left. This tells me down. This is telling me right. And this is also telling me down here. All right, domain and range, and then we will have finished this one up. Domain is telling me all the possible things that we could have as x values. So there's a couple things I notice about this graph. In between these arrows, stop that. In between these arrows, I can trace this graph without ever lifting up my pencil, right? So in between these arrows, I can get every single x value. I can get everything that's in between 2 and 3. That happens right here. Everything that's in between negative 2 and 1. Everything that's in between 1 and 0. And so on. I can get all of these different x values. When I see the arrows on the ends here, I know they're mostly pointing down, but this one is tipped ever so slightly to the left, right? It's going to keep going down, but it's also going to keep heading out to the left forever and ever and ever. What about on the right side? Same thing. All real numbers. All real numbers. You can write it out in words. You can use that R with the 2 sticks. Or you can write this using interval notation, the one with the parentheses. It keeps going to the left forever, so that would be negative infinity. It keeps going to the right forever, so that would be positive infinity. When I write it in interval notation for my domain, it's always smallest x first, biggest x last. There is no smallest x, it keeps going, so negative infinity. There is no biggest x. It keeps going to the right, so a positive infinity. Whew, last piece, range. Range is telling me about all the possible y values that could be parts of ordered pairs for points that are on this graph. If I were to ask you, hey, could you point to a spot on the graph, so on this blue M, where if you put your finger down on it, the y part of the ordered pair would be -1. Yeah, I can put my finger right here. I don't know what the x part is, but the y part is definitely -1 right here. Could you put your finger down on this graph somewhere where the y part of the ordered pair would be -3? Yeah, like right here. The x part is -2 point something, I don't know what, but the y part is -3. Could you put your finger down on this graph somewhere where the y part of the ordered pair is 0?
No. Yes, right there.
These guys. What about where the y part of the ordered pair is 1? Yeah. Like right here, the y part of that ordered pair would be 1. Could you put your finger down somewhere on this M-shaped graph so that the y part of the ordered pair would be 3?
No.
No. Why not?
Because
It only goes up this high, right? There are no y parts of ordered pairs that are bigger than this. All of the other y's are smaller than that. That's what I need to explain when I write my range.
y is less than or equal to 3.
Y is less than or equal to, what's the highest y value we found on here?
2.
Not all the way up to 2.
1.3.
1.3 or 1.5 or whatever you called it there. All the other y values are lower than that. If we wanted to write this using our interval notation, I start with what is the smallest y. When you look at this graph and you look at the bottom, because that's where the small parts are, what do you notice at the bottom of the graph? Does it stop? Does it have a lowest or a smallest y value? Then I would start with -infinity. It's always smallest first, and then I would give the biggest. What's the maximum y value, the highest y value? 1.3 or 1.2 or whatever you called it. I would use a bracket here because I can actually go and put my pencil on a point where this would be the y value. I can't touch -infinity, so he gets a parenthesis. If I can't touch it, it gets a parenthesis. If I can touch it, it gets a bracket. What else do you guys want to look at? Because that finishes up number 2. Number 13? Absolutely. Number 13. Ooh, we got lots of parts here. X and Y intercepts. When I'm talking about an x-intercept, the y part of the ordered pair is 0. So I would take that equation that they gave me, 3x minus 6, but then I'm going to put a 0 in the place of the y. And then I'm going to solve this. What's 6 times 0? 0. This whole thing just disappears, because if I subtract nothing, nothing changes. So I would have 3x equals 12. How do I get x by itself? Divide both sides by 3. So x is what? 4. So my x-intercept is 4, 0, because we put a 0 in for y in the equation. 1, 2, 3, 4. So right here. I'm going to do something very similar for y, except to find my y-intercept is y 0?
No, it's
X is 0. When I want y, x is 0. When I want x, y is 0. Whatever you don't want, make it a 0. So I have 3, and then I'm going to put 0 in the place of x, minus 6y equals 12. What's 3 times 0? 0. It disappears. I still have to remember that negative in front of my y, though. Bring your negative sign down. Don't forget that one. So I have negative 6y equals 12. How do I get y by itself?
divide by -6.
Divide both sides by negative 6. And I get y equals -2. So my y-intercept, we put 0 in for x, and we found out that y was -2. So right down here. Once I get those 2 points plotted, I grab my straight edge and I trace through them. Let's see if I can draw a slightly better line than that. There we go. So there's my line. Part B looks very similar, but what's the biggest difference on part B? Yeah, I have an inequality sign. When you see an inequality sign like this, we're going to put it in slope-intercept form. Y equals mx plus b. Here's y. It has a 2 next to it. I can't get rid of that yet. Is there anybody else on the same side of the inequality as y? 3. How do I make that cancel? How do I get rid of it? Yes, we're going to subtract it. So I'm going to subtract 3 from both sides. And I don't have any more room, so I'm going to have to bring my work over here. All right, so I have 2y less than 6x, -1 minus 3? -4. When I add and subtract things, my inequality always stays the same no matter what. What do I do now to get the y all by itself? Divide both sides by 2, and that means everything on the other side. Here's where we're distributing that division again. Some teachers will write it like this. That looks very similar to what we had in the bell work, right? When I write it down, I usually write it down distributing already, so that we don't forget to reduce. I divided by 2. Will that flip my inequality around? No. What type of number is it when it flips my inequality? Negative. If I have a negative on the bottom of my fraction that I put there, then my inequality flips. So y is less than 3x minus 2. This -2 right here, that is my y-intercept. So I'm going to go and put that on my graph right down here. What is the 3 then?
The mx.
Yep. That is my slope. That is m. It's 3, but I need rise over run. Yes, so it's 3 over 1. Top part tells me my rise. Bottom part tells me my run. And when I run, we always run to the right. So I'm going to go up 3, 1, 2, 3, and right 1. Up 3, 1, 2, 3, and right 1. Is that enough that I can grab my straight edge?
Mm-hmm.
Yes. Can I go backwards and get another point on the same line? I have to do everything backwards, though. So I can go down 3 and left 1 and get 1 more point. What kind of a line am I going to be drawing? Dashed. Why? Yes. It is open. It does not have that little line underneath it. So this is going to be dashed because of this. So I'm going to go ahead and draw that in. Grab my straight edge here. Make sure it is a dashed line. There's one more thing that I have to watch out for with this. What else do I need to do? I'm not all the way done yet. We have to shade it. So we're going to test a point. I like to test what point? Does anybody remember? 0, 0. Test 0, 0 for our shading. So I'm going to mark 0, 0 on my graph. This is what I'm testing. I'm going to go back to this original equation right here, and I'm going to put 0 in for y and for x. So I have 2 times 0 plus 3 is less than 6 times 0 minus 1. What's 2 times 0? 0. So on the left-hand side, I just have a 3 left over. I have a less than, what's 6 times 0? 0, so that disappears. What do I have left on the right then? Negative 1. Is the alligator eating the bigger number? No. This is false. 3 is not less than negative 1. So I am not going to shade the side of the line where my test point was. If I'm not shading that side, I have to shade which side? The other side, over here. When we get something that's false, we do not shade our test point. Make myself some more room to write here. If I'd gotten something that was true, then I would shade where that test point is. And I would not shade the other side. Only one side can be true. If one side is false, the other side is true. Always. So if I test my point and I get false, I'm going to go to the other side. How can I check it? How can I check to make sure I'd shaded this correctly now? I'm not sure. What can I do? Pick another point that's in the shaded side. So, is this on the shaded side? That's 3, 1. I can substitute that in and see what happens. Yes, sir. Yes, you may. So I put 1 in the place of y. That's supposed to be less than 6 times the x. What did we say the x part of that ordered pair was? For this point in the shaded region. I wrote it in black. What's the x part of that ordered pair? 3. And then minus 1. I'm just going back. This is my original inequality, but with the x's and the y's plugged in. What's 2 times 1? 2 plus 3 is 5. I'm going to bring this inequality down. What's 6 times 3? 18 minus 1. 17. Is the alligator eating the bigger number? Yes. This is true, so that means it should be shaded. And it is. We picked it out of our shaded space. So that's how I can always be sure that I've shaded the correct side. All right. C and D yet. By the way, guys, I'm posting the video for all 3 sections of my Algebra 2 class today, so if you had a question that you wanted to hear me talk through, and I didn't go through it in this class period, that does not mean that it won't be in any of those videos, okay? A way that you can tell whether or not it shows up in those videos is in the notes for today. I will post my work even though all my solutions are already posted as well. And so if you see that there's work showing up in the notes that you're like, we didn't do that one in class, it's in one of the other videos. Okay. I'm going to start with D and then I'll end with C because D is faster and easier even though it looks more confusing. How many rules do we have? 2 rules. I've got this one right here and I've got this one down here. How many fences do we have splitting apart these 2 rules? 1 fence. Where's it at? No, right here.
2?
Yep. There is a fence at 2, and this is always going to be a vertical line, like because it separates my yards out. So at 2 over here, for my own benefit, I'm going to draw in this little fence so that I know who lives on which side. The one that I circled in blue, does that live on the left side or the right side? left side. It has a less than. So this one lives on the left. So negative x plus 1 lives over here. Down on the bottom, I see a greater than or equal to, so this is on the right. And it says it's just the constant 2. When it is just a number here, it is a horizontal line. So starting right here on the fence, I'm up at 2 on the y-axis, and it goes like this. Whole number, flat line. The other rule lives on the other side. I have slope-intercept form. This plus 1 is my y-intercept. I have the y-axis in this yard, so I'm going to go ahead and put that point on there. What's my slope? Close. Down 1. My slope here is negative 1 coming from this right here. So negative 1 over 1. So down 1, right 1. Down 1, right 1, but only until I hit the fence, and it gets an open circle. Why does it get an open circle where it hits the fence? Yeah, the inequality didn't have that or equal to with it. So I have this line that comes and hits my fence. It keeps going off to the left because that's his yard, but he doesn't go past the fence. So far, so good? All right. I'll see how far I can get on part C. What kind of function is part C? Yeah. I've got those bars on either side. This is an absolute value. The parent for an absolute value is y equals absolute value of x. I'm going to start with this idea right here. I'm going to make a table for my parent, and then I'm going to use that with the transformation to figure out where this graph lives. Absolute value means what? How far away it is from 0. I want to know the absolute value of x. So I'm going to pick out some numbers for x, and you're going to tell me how far they are from 0. That's going to give me my parent table. So I'm going to start with negative 2. How far is that from 0? It is 2 units from 0. So I have a point at negative 2, 2. What about negative 1? How far is that from 0? 1 unit. Yep. So right here at negative 1, 1. What about 0? 0 units from 0. Right here. How far is 1 from 0? 1 unit away. How far is 2 from 0? 2 units away. So I plot that point. So here's my parent function. But they wanted me to graph this other thing that's not the parent. Minus 3. Is that AH or K? That is A. What will the negative part do to it? It will reflect it over what? Yes, reflect over x-axis. What will that whole number 3 part do to it? Stretch or compress? Stretch. This is going to vertically stretch it by 3. If I'm talking about vertical things, does that affect x or y? Y. I'm going to take my A and multiply it to my y's. What is that plus 1 on the end? Who is that, AH or K? That's K. What will that do to my graph? Up 1. Will that affect the x's or the y's? The y's. So I'm going to add 1 to each of these after I multiply them by negative 3. So what's h? Be careful. Who is this? That minus 2 is what? Minus 2 is Is it H? It's where I go looking because I want H, but who do I actually see in the equation? I see the opposite of H. I see minus 2, which means H is actually what?
2.
H is 2. So I'm going to take H. That's going to shift it to the right 2. Will that affect my X's or my Y's? X's. I'm going to add 2 to each of these. All right. Have a great rest of your day, guys. Please let me know if you have any questions. Send me messages through Canvas if you need help with anything.